Circle, circle, circles. Still not sure what pi means. Radius, diameter, circumference. Where does pi fit in here? I just don't get it. Well, let's look at these notes again. Circles are among the most important of geometric concepts. We use them in machinery, in building, in art, for beauty and for utility. Yes? What else did Mr. Leonard tell us in math class about circles?
Wheels are circles. And wherever we have built moving machines, from wagons to automobiles, we have used wheels, or circles. To visit a shop where tools are used is to see many circles being put to many different uses. For a circle is useful, and it is beautiful.
But how does that help me to understand pi?
To understand circles, we must study them. Let's begin by getting our terms straight. Using a compass, it is easy to draw a circle. What are the terms to consider?
Well, the center is the point around which the circle is described or drawn. Every point on that line is the same distance from the center. Any straight line from the circle to the center is a radius. And any straight line through the center, with its ends on the circle, is a diameter. The length of this line, the circle line, is the circumference. And that's as far as I got before. Except I drew a lot more circles. But what's this about pi?
To understand circles means to be able to measure them and compare measurements. Go ahead, John. You can do it. That yardstick ought to do the job. Now, make a point in your circle so you'll know where you began to measure. Just roll your circle over the measuring stick until the arrow comes around again, and you have the length of the circle, or the circumference. It's 31 7/16 inches. You can measure a circle after all.
It isn't hard to measure the diameter directly. If measuring will do it, well, here I go.
And now you should know a lot about circles. Maybe even something about pi. You've measured a lot of circles. This sprocket wheel with a diameter 8½ inches long has a circumference of
26 5/8 inches. But still, what about pi?
In studying the circumferences and diameters of circles, you should notice something important. A circle with a diameter 2 inches long, the circumference of the circle is more than 6 inches long. A circle with longer diameter, say 3 inches, has a longer circumference too. That's just common sense, of course. The longer the diameter, the longer the circumference.
Let's keep going. I'm getting it.
Suppose you take the circle with diameter of 3 inches. You place that circle carefully, you measure that. You rotate the circle until you measure the circumference, and you record these measurements. Then you measure another circle. This circle has a diameter of 1 inch. You carefully prepare to measure the circumference of this circle. You find the circumference, and you record these measurements. These are the facts which have helped teachers of mathematics to develop the meaning of pi.
I think I'm beginning to understand, but not quite.
Let's think of the facts in a different way. Suppose we think of the two circles at the same time. Our small circle with a 1-inch diameter. Our large circle with a 3-inch diameter. We know already the circumference of each of these circles. Now, let's compare the length of the diameter of the small circle with its circumference. We can see this comparison by seeing how many diameters it takes to equal the circumference. We can see that it takes 3 diameters and a little more to equal the circumference of the small circle. What about the large circle? How many diameters will it take to equal the circumference of the large circle? Once again, we see it takes 3 diameters and a little more to equal the circumference.
Is that true of all circles? The 3 and a fraction diameters of any circle equal the circumference of that circle? I should be able to answer that. Let's figure the ratio of those I've measured. Ratio of circumference to diameter. My first measurement was circumference 31 7/16 inches, diameter 10 inches. 3.14. Well, I guess that proves something. They're all so nearly the same. Every one of them. You know, that's quite a discovery. The circumference is a little more than 3 times the diameter.
We usually use 3.14 as pi.
I didn't need to measure the circumference. To find the circumference, I could have just measured the diameter and multiplied by 3.14. And why couldn't I understand that when I read it before? Pi. Mathematical. The letter pi denoting the ratio of the circumference of a circle to the diameter. I'll bet I've read that a dozen times before and didn't know what it meant. The ratio of the circumference to the diameter. The value of this pi to 8 decimal places is 3.14159.265. Wow.
Pi can be written in many ways. All these are symbols for pi. To find the numerical value of this important ratio was one of the great problems of history. From the Old Testament, it is evident that the Hebrews considered the value of pi to be exactly 3. The ancient Egyptians apparently had some knowledge of the value of pi, but it was in Greece that the value of pi was more accurately determined. And from the Greek alphabet comes the name. The 16th letter of the ancient Greek alphabet is still used to name the relationship of the circumference of a circle to its diameter, 3.1416, sometimes used as 3 1/7 as a matter of convenience.
Pi. That's what I discovered just now. A circle. A radius. A diameter. And pi.